Okay, so today's lesson is quadratic formula and the discriminant. So standard form of quadratic is ax squared plus bx plus c. And we had done several different methods in solving. So completing the square to solve this equation basically ends up leading you to the quadratic formula. So this is our quadratic formula. If you'll notice on the inside of this square root here, we have b squared minus 4ac, and that portion there is referred to as the discriminant. So just this little piece inside. And the reason why that discriminant is important is because, as we know, when we take the square root of a number, positive number in particular, we would get a positive and a negative answer, which is why that plus minus is already there in the formula. If you end up with a 0 inside this discriminant, then that means you're just going to have the one answer because square root of 0 is just 0. But if you end up with a negative inside there, just as a reminder, the square root of a negative will give you two imaginary solutions. You'll have the plus and the minus, but you'll have two imaginary solutions. So before we go through and use the entire quadratic formula, I'm going to skip ahead to just the discriminant, and we're going to talk about that a little bit more so we can see how that affects different parts of the quadratic equation. So this part, the part that's under the radical sign, which like I said is b squared minus 4ac, is called the discriminant, and it can be used to determine the types of solutions and the number of x-intercepts. So if the discriminant is a positive number, like 4, which is also a perfect square, this would mean that it is factorable. So the quadratic equation itself would be factorable if you were trying to factor it. And it means that it has two real or rational x-intercepts or roots. So if it has two real roots and they're rational, then we know that when we graph it, it's going to go through the x-axis at some type of a point that's maybe, a whole number, an integer, or maybe a fraction. Now, again, the graph could go upside right. It can also go upside down, depending on if the a value is negative or positive, right? But in any event, it's going to go through at a whole number, an integer, or some kind of a fraction or rational number. Now, we can also get a positive discriminant that's a non-perfect square, like 72, for example, and this would mean that it would not be factorable if you were looking at the equation in standard form. And so it's still going to have two x-intercepts on the graph, but it's going to cross at kind of like random spots. So it's never going to cross on one of those corners of a box there because that's all your integers or your whole numbers. And even this little fractional place that where it's crossing, it's actually going to be an irrational number, so it'll definitely be some kind of a decimal. So because the positives have square root of a positive number has two solutions, a positive and a negative, that's why we have our two x-intercepts on those graphs. Now, as I mentioned previously, if you have a negative number inside your square root, such as negative 576, for example, you're going to get two imaginary solutions. And if you attempted to graph it, you would see that your parabola will not actually intersect the x-axis. Once again, this could happen upside down, upside right. Either way, you can still graph the parabola, but you do not have x-intercepts that are viewable on your coordinate plane. And finally, you could get a 0 inside the square root, so your discriminant would be a 0, and this would mean that there's one real rational answer, and it's considered a double when you factor. Now, as far as the graph is concerned, it would look like your parabola is going to come down. It's going to hit the x-axis in that one location and then bounce back up. If you were to factor that original quadratic equation, you would have the same answer twice, which is why it's referred to as a double. Same thing would happen if you had a quadratic that was going to open down. It would still only come into contact with that x-axis in one location. So note the equation must be in standard form to calculate the discriminant. Okay, so let's work a little with these discriminants. So finding that discriminant, which is just that b squared minus 4ac, and giving the number and type of solutions of the equation. How many x-intercepts does the graph have? So first of all, we have a, b, and c. So when I go to do my little discriminant here, I'm doing 6 squared minus 4 times 9 times 1. This ends up being 36 minus 36, which of course equals 0. This means I have one real solution, and I would have one x-intercept. All right, so for number 2, a, b, and c. So b squared minus 4 times a times c is 36. And here 4 times 9 times 4, and there's 2 negatives. That's going to be plus 144. And then when I add those up, I get positive 180. So that means I will have 2 real solutions. Since 180 is not a perfect square, these will be irrational solutions. And I will also have 2 x-intercepts. Okay, the next one, we have to move that 5 over to the other side first. You have to make sure that it's equal to 0 before you attempt to identify your a, b, and c. So now I can do 6 squared minus 4 times 9 times 5, 36 minus 180, and that gives me, I believe, negative 144. So because I have a negative, that tells me I'm going to have 2 imaginary solutions, which means I will have no viewable x-intercepts. So just moving along, trying a few more of these just to kind of get the idea here. Okay, so next one, this time my a is 1, my b is 5, my c is 2. So 5 squared minus 4 times 1 times 2. 25 minus 8 leaves me with 17. It's a positive, so I have 2 real solutions. However, they will be irrational since 17 is not a perfect square. But I will also have 2 x-intercepts. All right, next one. Again, we have to move the c term over to the other side of the equal sign, but it's in standard form. Now I have a, b, and c. So negative 4 squared minus 4 times 4 times 1. 16 minus 16 gives me 0. That means I have 1 real solution, and I would have 1 x-intercept. All right, and moving on. So over here I have a, b, and c. So my b squared, 3 squared minus 4 times negative 2 times negative 7 gives me 9 minus 4 times 2 is 8, and then 8 times 7. So you just end up with a minus 56. 9 minus 56 is negative 47. The negative tells us we're going to have 2 imaginary solutions, and we will have no visible x-intercepts. Okay, number 7. Okay, again, we're going to move this x over. Just be careful when you move it over. It goes actually in the middle here in order for it to be in standard form. So now I have a, b, and c. So negative 1 squared minus 4 times 5 times negative 13. So I have 1, and the minus and the negative is going to make this a plus. And when I multiply 4 times 5 times 13, I have 260, which gives me 261 for my discriminant. Positive answer means I have 2 real solutions. These will be irrational, and I will have 2 x-intercepts. Okay, and then the next one here, again, I got to move that 1 over. So 64x squared minus 16x plus 1. A, B, and C. So negative 16 squared minus 4 times A times C. So 16 squared is 256. And then we have 4 times 64, which is also 256. And that's going to equal 0, which of course means we have one real solution and one x-intercept. And then finally, our last one here, we're going to move the 20x over, which will make it a positive 20x. And then that 25 will become a negative. A, B, and C. So 20 squared minus 4 times negative 4 times negative 25. 20 squared is 400. 4 times 4 is 16 times 25, or you could have done 4 times 25, which is 100, times 4, you get 400 either way. We have 3 negatives, so it's going to stay negative, and that equals 0 as well, telling me I have one real solution and, of course, just one x-intercept. Okay, so hopefully now you have a good idea of how to find the discriminant and also what that discriminant tells you about the equation and also about the graph. We can now go back to our quadratic formula and kind of like finish it up and get those two solutions. So by doing the discriminant, first, you kind of have an idea of like what to expect. So if I do my discriminant first, then I know, okay, how many solutions am I going to have? Am I going to have an imaginary solution and all those kinds of things? Also, I know what it would look like on a graph. And then I can go from there and finish it out and find those solutions. So I'm going to continue to do my discriminant first. So obviously you want to make sure it's in standard form, which it is, it equals 0. Then we identify our A, B, and C. So for me, I'm going to just do my discriminant first. So 8 squared minus 4 times 3 times negative 35. Now 8 squared is 64, and then 4 times 3 is 12, and 12 times 35 is 420, and minus a negative will make that a positive 420. So my discriminant is then 484. So if I want to then use my quadratic formula that you see up here at the top, I now know I have negative 8 plus or minus the square root of, is that 484, over 2 times A. Okay, now at this point, it would be helpful to know if that square root was a positive. We know it's not 0, we know it's not a negative. But if it is not only a positive, but a perfect square, that'll be nice because it'll be an integer answer. So I'm going to just use my calculator. The square root of 484. And it would be a good idea to just check any number you're not sure of. Now this one happens to be a perfect square, which is 22. So it'll be a lot easier to just simplify it now and then go ahead and work out our two final answers. So negative 8 plus 22 over 6, and then we'll do negative 8 minus 22 over 6, and we'll get those two answers. So negative 8 plus 22 is 14. 14 over 6 is 7 over 3. So that's one answer. And then negative 8 minus 22 is negative 30. And negative 30 over 6 is negative 5. So notice we had two real answers, and they were both rational. Now, if we want to go on to number 2, we have to first put it in standard form. So we're going to move that 4 over. Now I know A is 1, B is negative 2, C is negative 4. So again, I'm going to start out with my discriminant because I have to find that out anyway. And it's a little bit easier to do the rest once you have the discriminant simplified. So this is 4 minus a negative will become a plus 16, and that gives me 20. Now this does tell me I'm going to have two solutions because it's positive. However, it's not a perfect square. So at this point, you might want to simplify or reduce that radical. So it's going to be 2 radical 5. So then when I go to put it in my quadratic formula, right, this is 2 times 1. We know that when we have a negative and then a negative on the b value itself, that's going to become a positive. We know that if we break down the 20, we get 2 radical 5, and 2 times 1 is 2. So this is basically our answer right here. However, sometimes you may see this simplified. So 2 divided by 2 is 1. And over here, the 2's can cancel out as well. So you could just end up with 1 plus or minus radical 5. So that really should be your simplified answer. If you're doing a multiple choice, that's what you would be looking for. All right, so those are both examples with positive discriminants and how that worked out to find our 2 solutions. So now let's look at 2 more. All right, so the first thing we want to do with this one is bring that 13 over. So if I bring my 13 over, negative 5 minus 13 would be negative 18. And now I'm going to divide up, getting myself A, B, and C. So we have 12 squared minus 4 times negative 2 times negative 18. So we know that 12 squared is 144. And then we have 4 times 2, which is 8, times 18, which is another 144. Because we have 3 negative signs there, that's going to remain negative, giving us a 0. Now we know that that's going to have one solution. So I have negative b plus or minus the square root of 0, 2 times the negative 2. That was my a value. So that's going to just simplify to negative 12 over negative 4, which of course just equals one real answer of 3. And that's what we would have predicted because we had a discriminant of 0. So now let's take a look at the next one here. So A, B, and C, it's already in standard form. So 2 squared minus 4 times negative 1 times negative 2. So it's going to be 4 minus 8, which is negative 4. So of course, this is going to be imaginary answers. So when I put it into my quadratic formula, I have negative b plus or minus the square root of negative 4, and that's going to go over 2 times a. So negative 2 plus or minus 2i over negative 2. Now for this one, we want to simplify because negative 2 divided by negative 2 is obviously 1. And 2 divided by 2 here is 1. And even if it's a negative 1, it doesn't really matter what the sign is because you have that plus minus accounted for. So you're just going to have 1i. So your final answer would be 1 plus or minus I. All right, so let's do 2 more. So number 5, we have to move the 35 over first to make sure that it's in standard form. So this would be A, B, and C. So to find my discriminant, I'm going to do 8 squared minus 4 times 1 times 35, which gives me 64. And then 4 times 1 times 35 is 140. And it's going to be a minus 140. So 64 minus 140 leaves us with a negative answer, which tells us we'll have 2 imaginary solutions. So now putting the rest of this into the quadratic formula, I have a negative 8 plus minus the square root of negative 76, and that's going to go over 2 times a. Of course, the double negative makes that 8 positive. 2 times 1 on the bottom is just 2. And then the 76, we're going to need to simplify that, right? So if we do 76 divided by 2, wait a minute. 76 divided by 2 is 38. And if you do 38 divided by 2, you get 19. So we have a pair of 2's plus the I from the negative, and then there's going to be a 19 in there. Now, these both have 2's outside the radical or something divisible by 2. So 8 divided by 2 is 4. 2I divided by 2, the 2's cancel. So we're just left with I radical 19. And that would be your answer for number 5. Okay, and then this last one, I'm going to move over that 19, make it into standard form. So now my A is -1, my B is 7, and my C is -19. Discriminant, 7 squared minus 4 times -1 times -19. So 49, and then 4 times 19 is going to be 76. And it will be a minus because we had the 3 negatives. So now when you do 49 minus 76, you're going to have -27, which is going to be another imaginary solution, or 2 imaginary solutions. So -7 plus or minus the square root of -27 over 2 times A, which is -1. -7 plus or minus over -2. And then we have to simplify that 27. So 3 and 9, 3 and 3. It's going to be 3I radical 3. Now, the only thing we have to simplify here is these 2 negatives, because you can divide -1 out of, since there's a negative on the 7 and on the 2, you really don't need those negatives there. And theoretically, you could cancel out the negative on the 3, but it doesn't matter because you have to have a plus minus there. So the sign on the second number isn't really that critical because you're going to account for both options anyway. All right. So hopefully now you kind of get an idea of how to find the discriminant, what it's used for, and how it helps you find and solve quadratic formula. So the last thing we're going to do is we're going to do a couple word problems using our vertical motion model, which is most easily solved with the quadratic formula. Now, in previous lessons, we talked about how to use the object dropped model when there's no force or velocity behind the object, and it was just simply falling or dropping. But now we're going to add in this extra piece here to account for that velocity or that initial force behind the object. So that's why we say it's been thrown or launched. It's not just falling, okay? So you're hitting baseballs, and when tossing the ball into the air, your hand is 5 feet above the ground. You hit the ball when it falls back to a height of 4 feet. If you toss it with an initial velocity of 25 feet per second, how much time will pass before you hit it? So it's one of those situations where maybe you have this person and they're basically throwing the ball up, and then when it drops down, they're going to hit it with this bat, right? So they start out holding the ball at 5 feet in the air, and then they wait till it drops about 4 feet in the air to hit it. Now notice this is still making a little parabola. So anything that you're doing in one of these kind of problems, if you made a path of the motion of that object, it should make some sort of a parabola or a portion of a parabola. So we know that the starting height, or that h sub 0, was 5 feet, and the ending height, which is just the regular h, was 4 feet, right? And then the velocity was positive 25 because it was tossed upward. Any object moving upward first has a velocity that's going to be positive. Any object that'll be pushed downward is actually going to have a negative velocity. And now we're simply just going to plug them into this equation in for these 3 variables. So we would have 4 equals -16t squared plus 25t plus 5. Now, just like solving any other quadratic equation, you need to make sure it equals 0 first. So we're going to subtract the 4 over. So now we have 0 equals -16t squared plus 25t plus 1. Just as I did on all the other problems, I'm going to now use this to find my discriminant. So over here on the side, I'm going to do my discriminant first. So that will be 25 squared minus 4 times negative 16 times 1. Now this might be where it might be helpful for you to use your calculator. I believe this is going to be 625 plus 64, which is 689. If you need to use a calculator, please by all means. So now typing this in, we have negative b plus or minus the square root of 689 over 2 times a, which is pretty much always going to be negative 32 because 2 times negative 16. And if I want to check my square root of 689 on the calculator and see if it's a, hold on, see if it's a perfect square. Usually they're not in these types of problems because you are dealing with some kind of wild numbers. So you can see that it's not. All right, so if it's not a perfect square, then we can just basically put this into our calculator 2 times and get the 2 different answers. So first I'm going to do negative 25 plus the square root of 689. So negative 25 plus the square root of 689. Now make sure you hit equals, then divided by that negative 32. Otherwise, you'll need extra parentheses. So I get negative 0.04. I'm going to round that to. And then my other one, I will just do the opposite with the minus sign. So negative 25 minus the square root of 689, hit equals, then divided by the negative 32. And that's 1.60. 1.60. Now notice in these two options, the negative answer would not be a viable option because you can't have negative time. So the complete answer would be 1.61 seconds. And that would be how long the ball was in the air for before it was hit. Okay, so we're going to do one more of these. The only difference with this problem is going to be that it's going to have that motion downward like I talked about earlier. So in a volleyball game, a player on one team spikes the ball. So that's kind of when they come up on top of it and they just like slam it into the ground. So it's not going to go up at all. It's just going to be propelled towards the ground. And they do this when the ball is 10 feet above the court. The spike drives the ball downward with an initial velocity of negative 55 per second. So that's why we're using the negative 5 here. It can't really travel a negative speed, but the negative indicates the direction. And then the player on the opposing team have to hit it back before it touches the court. So that would mean that my ending height is 0. So we know the starting or initial height was 10. That velocity was negative 55, and the ending height is 0. So 0 equals negative 16t squared minus 55t plus 10. And then I'm just going to go ahead and do my quadratic formula with the discriminant. So my discriminant, I have negative 55 squared minus 4 times a times c. Oh, and I think I forgot my negative 16 on there back. So negative 55 squared, we're going to use a calculator for that. We get 3,025. And then 4 times 16 times 10 is 640, and that's going to be a plus. So this is going to be 3,665 for the discriminant. So x equals negative 55 plus or minus the square root of 3,665 all over 2 times a, which is that negative 16. So of course we simplify this to just 55 and negative 32 on the bottom. And now you can put those two different options in the calculator. So if you're going to do 55 plus the square root of 3,665, make sure you hit equals before you divide it by the negative 32. And we get negative 3.61. And then we do it again with that minus sign in there. So we're going to do 55 minus the square root of 3,665 and divide that by negative 32, 0.17. And the general rule is to round to the nearest hundredth. Okay, now once again, the negative answer does not make sense. The positive is the only one that can represent time. So the proper unit of time here would be seconds, so 0.17 seconds.